There are two types of circuits we can make called series and parallel. The components in a circuit are joined by wires. If there are no branches, then it's a series circuit. If there are branches, it's a parallel circuit. In this lesson, we are going to look at a parallel electricity connection. First, we are going to build a parallel connection. In electricity, a node is where two wires are joined together or a place where two ends of a terminal are connected or joined together. So now we are constructing our parallel circuits by joining together our wires with our bulbs as can be seen. In this circuit, one battery, wires, a switch, and 3 bulbs are connected together. As you can see, when the switch is turned on, all the 3 bulbs shine with the same intensity. You can see the flow of the electric current is from the negative terminal of the battery and flows through the switch. The bulb and back to the battery through the positive terminal. You can see that we are using a 9-volt battery, and there is no resistance in the battery and the switch. The resistance in the bulbs are 10 ohms. You can see that if we reduce the voltage of the battery from 9 volts to 0, the bulb will stop shining. This means there's no power left in the battery. At 3 volts, the light shines very dim. At 50 volts, the light shines very bright with a high intensity. The flow of electricity through the circuit is very fast. We can see that when we increase the resistance of the battery from 0 to 1 to 5 ohms to 10 ohms, we can see the bulb begins to glow dim and dimmer. Now we are going to add 2 batteries and see how the bulb will shine. We can see that the bulbs are shining very bright and intense, and the electricity is flowing through the circuit faster. Now we are going to add 1 more bulb to the bulb in the 3rd row, and you see how these 2 bulbs will shine compared to the other bulbs. Notice that these 2 bulbs are now in series with each other. You can see that these 2 bulbs are not shining very bright because they are now in series with each other and are sharing the electricity flowing through them. The other bulb in the middle and the top are shining very bright. Now we are going to remove 1 battery from the circuit and see how the bulbs shine. Now we are going to add another bulb to the 2 bulbs at the bottom. Now we have 3 bulbs in series, and we are going to see how they shine. You can see the 3 bulbs at the bottom are shining even dimmer than before. Observe the flow of electricity in 3 rows. You can notice that the electricity in the 3 bulbs in series is flowing even more slower than the other bulbs in the middle and the top. Now we are going to add a 10 ohms resistor to the bulb in the middle. A resistor reduces the amount of electricity flowing through the electrical component. You can see that the middle bulb is not shining that bright like before. If we increase the resistance of the resistor from 10 ohms to 18 ohms, we can see that the middle bulb shines even dimmer. If we increase the resistance to 25 ohms, the bulb glows very dim. The more we increase the resistance of the resistor to 40 ohms, the light is almost not shining. In a parallel circuit, if a lamp breaks or a component is disconnected from one parallel wire, the components of different branches keep working. And unlike a series circuit, the lamps stay bright if you add more lamps in parallel. Parallel circuits are useful if you want components to continue to work even if one component has failed. This is why our homes are wired up with parallel circuits.